This is section 4.2, degrees and radians. Your I can statements for this section. I can convert degree measures to measures of angles to radian and vice versa, and I can use angle measures to solve real-world problems. So an angle is two rays that meet at a common endpoint. That common endpoint where they meet is called the vertex. An angle can also be thought of as by being formed by the action of rotating a ray about an endpoint. So if you have your ray, we can think of an angle as taking that ray and rotating it however far until you get to the other side of your angle. So the initial side is that one that's always on the x-axis. It's the starting position before it's rotated. The terminal side is the final position of the ray after it's been rotated to make the angle. Now we know it's going to be in standard position if you start your ray at the origin and you have your initial ray on the x-axis, and then you rotate to get to your angle. When we measure angles, if it is going counterclockwise, we say it's a positive angle, and if it goes clockwise, it would be a negative angle. Now if we break up a circle into degrees, when we start over here, we are at 0 degrees. We go 30, 45, 60. When we get to the top, that's 90. This would be a right angle with the x-axis. We go around 180, 270, and when we get back over here, this would also be 360 degrees. So if you do one full circle, that is 360 degrees. Now degrees can be expressed using a decimal degree form or a degree, minute, and second form, or a DMS. When we do degree, minutes, and seconds, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. So we need to convert from decimal to DMS or DMS back to decimal degree. If they give this to you as a decimal, we're going to start with whatever your whole number is. You're going to leave that part alone. So we're at 56 degrees. Now we're going to take our decimal and we're going to multiply it by 60 because there are 60 minutes in 1 degree. So we're going to do 0.735 times 60 minutes. And if we multiply that, we are going to get 44.1 minutes. So again, we can take this whole number, bring it down. So we have 56 degrees, 44 minutes. Now we have to figure out how many seconds. So we'll take our decimal part of this, 0.1, and we're going to times that by 60 seconds because we know there are 60 seconds in every minute. And if we multiply this, we are going to get 6 seconds. So 56.735 degrees is equivalent to 56 degrees, 44 minutes, and 6 seconds. This is one way that we use this in surveying. When people survey land, they don't do decimals, they do degrees, minutes, and seconds. So if you're looking for long distances but you need a very accurate angle measurement, in surveying would be one example of where you would use this. Now if we take this and we work this backwards to figure out how many seconds 28 seconds is minutes, we're going to take 28, we're going to divide that by 60, and it's going to give us a decimal of 0.466 minutes. Now we're going to add this to our original number of minutes, so we have 5.466 minutes. We're going to divide that by 60 because we know there's 60 minutes in every degree, and if we divide here, we're going to get 0.091. So if we add that to our degree, that means we have 32.091 degrees. A radian is the measure theta of a central angle of a circle, and it's equal to the ratio of the length of the intercepted arc to the radius of the circle. So to find your measure, radians is just another way to measure an angle, but we do it in a different form. They take the arc length, which is your S, and we divide that by the radius of your circle, and that'll tell you the measure of the angle in radians, which we call theta. So our most common radian measures, one full rotation is 2 pi, half a rotation is pi, a quarter of a rotation is pi over 2, and a sixth of a rotation is pi over 3. A sixth of a rotation you can think of as 60 degrees, a quarter is 90, a half is 180, and one full rotation is 360. So 2 pi and 360 degrees are equivalent. Pi over 3 radians and 60 degrees are also equivalent. Now, if it isn't one of those easy ones, we do have formulas to convert from one to the other. If you are in degrees and you need to be in radians, you can multiply by pi radians over 180 degrees. And if you're in radians and need to go to degrees, you multiply by 180 degrees over pi radians. So if it's in degrees, the easiest way to start is to put your degree over 1. Then you multiply by pi over 180. We simplify if we can. We know 60 goes into 120 2 times. 60 goes into 180 3 times. We can't reduce any further, so we multiply straight across. 2 times pi is 2 pi. 1 times 3 gives us 3. So 120 degrees is equivalent to 2 pi over 3. Next we have negative 45 degrees. Again, we're going to put this over 1. You multiply by pi over 180. 45 actually does go into 180. So if we do 180 divided by 45, we'll see that it goes in 4 times. So 45 goes into itself once. It goes into 180 4 times. If you need to do like 9 first and then 5 and get reduced down, that's fine as well. If you multiply straight across, negative 1 times pi is negative pi. 1 times 4 gives us 4. So negative 45 degrees is equivalent to negative pi over 4. Now we have 2 radian measures, and we need to get back to degrees. To do this, you multiply by 180 over pi instead. Those pi's are going to cancel. We're going to see if we can reduce any farther. 6 goes into itself 1 time. 6 goes into 180 30 times. If we multiply straight across, 5 times 30 gives us 150. 1 times 1 is 1, or that's just 150 degrees. On the last one, it is in radians, so again we are going to multiply by 180 over pi. The pi's are going to cancel. 2 goes into itself once. 2 goes into 180 90 times. Negative 3 times 90 gives us negative 270 over 1, or negative 270 degrees. Two angles are coterminal angles if they terminate at the same position. So they may not be the same degree measure, but as long as they end in the same place, they are coterminal. So positive 90 degrees and negative 270 degrees would end at the same point. So those are coterminal. You can have negative coterminals or you can have positive coterminals. In degrees, you're going to find your coterminals by taking your angle measure, which we're going to call alpha right now. We're going to take our alpha and we're going to add 360n. N can be any positive integer. So we can add 360 or we can add 720 because that's 360 times 2. Or you can do a times 360 times 3, and you can go on and so forth. You can also add negative ones. So we could do alpha plus negative 360 because we're multiplying with a negative 1 for our n. If it's in radians, your alpha or your angle, you're going to add 2n pi, because one full circle is 2 pi. And then we can change that to make it positive or negative by changing that n value. So we're going to identify all angles that are coterminal with the given angle. Then we're going to find and draw one positive and one negative coterminal. So all of the coterminals would be 45 plus 360n. Because this is in degrees, we do use 360. So it'd be 45 plus 360n. Now we need to actually draw this. So 45 degrees would be right here. We need to find one positive and one negative. The easiest way to get a negative is just to add a negative 360. So if we do 45 plus a negative 360, that's going to give us a negative 315. So to demonstrate this, we just start at the x-axis, but we go clockwise instead until we hit that terminating side, and that's negative 315 degrees. But we also need to find a positive coterminal. To do that, we can just do 45 plus 360. And that would be 405 degrees. So we still start at the x-axis, we still go counterclockwise, but we go past it and then we stop when we hit it the second time. So that would be 405 degrees as our coterminal. We can do the same thing in radians. Remember, pi over 3. If we want, we can convert that to degrees so we can have an idea of where that would be located. So if we multiply by 180 over pi, the pi's are going to cancel. 3 goes into itself once, 3 goes into 180 60 times, so this is equivalent to negative 60 degrees. So the first thing we need to do is to name all of the coterminals. To do this, we would say negative pi over 3 plus 2n pi. That's how you would find all of the coterminals. When we graph the angle itself, negative 60 degrees or negative pi over 3 would just be located here. Now, because this is already a negative, to get a positive coterminal, we can actually just add 2 pi to this. The easiest way to do this is to make the denominators the same. So we're going to need the denominator to be 3. We multiply both sides by 3. This is 6 pi over 3. So if we add that, 6 pi, and this is a negative, so 6 pi plus a negative pi over 3 will give us a 5 pi over 3. So if we start here and go in the positive direction and stop here, this is a positive 5 pi over 3. If we need to do a negative version of this, I can say negative 2 pi plus negative pi over 3, or negative 6 pi over 3 plus negative pi over 3. Negative 6 pi plus a negative pi is just negative 7. So we start here, we go around until we come back and hit that again, and that is negative 7 pi over 3. But it is negative, so that's why we are going clockwise.